Aloha and good morning. Welcome to the final installment of the Women in Space Exploration Talk Series. Before we get started, we'll hear a brief message from Pisces Director Rodrigo Romo.
Aloha, everyone. This has been a fascinating week with the presentations from 7 amazing women covering incredible projects related to space exploration. And if that wasn't enough, this week also 3 women scientists received Nobel Prizes in chemistry and physics, 2 of them with ties to the Big Island. All in all, it's been a wonderful week for women in science. I want to express a heartfelt mahalo to our 7 panelists: Jessica Dempsey from the East Asia Observatory, Nadine Cox from JPL, Emily Calandrelli from the Netflix show Emily's Wonder Lab, Sarah Langberg from AirVironment, Monsi Roman from NASA, Amanda Hendricks from the Planetary Science Institute, and today's speaker, Barbara Belvisi from Interstellar Labs. You all are a true inspiration to many young future scientists and engineers, and the work you do is of unique value to the entire human race. I also want to spend a special thank you to our collaborators in this program, Mark Dowd and Christina Cook from Microsoft for providing the platform and tech support that hosted the program, Christian Wong from the Hawaii Science and Technology Museum, who made the Hawaii Interpreting Services available for this series, and of course to our rock star moderator and MC Mimi, whose energy and enthusiasm is contagious and brought these talks to a whole different level. And last, but certainly not least, a very special and sincere mahalo to the person who really made this happen, Chris Yoakum. He is the one who organized and coordinated this event, got all the promotional material out. Mahalo nui, Chris. You have done, once again, an out-of-this-world job. With that, I'll hand the program over to Mimi. Enjoy Barbara's talk, ask questions, learn a lot, and stay safe. Ahui ho, and until we meet again, aloha.
Mahalo, Rodrigo, for such a wonderful welcome. My name is Mimi Fuchs. I'm a space enthusiast. I spent the better part of the last 5 years working in telescope operations for the Mauna Kea observatories, and now I'm back in school, like a lot of you who are tuning in, studying engineering. I'm so excited to be here with you today. This is the final installment of our Women in Space Exploration Talk Series. As Rodrigo said, a big mahalo to everyone who has made this talk series possible. And we are so excited to have Barbara Belvisi today here with us, the founder and CEO of Interstellar Lab. Barbara is the founder, CEO, and product lead at Interstellar Lab, whose mission is to design and build closed-loop habitats and systems for humans to live in a regenerative way on Earth and beyond. Prior to Interstellar Lab, Barbara co-founded Hardware Club and worked with more than 400 robotics and hardware companies worldwide and helped launch several startup incubation programs. Barbara is one of the youngest women founders of a venture capital fund in Europe and was ranked among the top 10 women in tech in France in 2018, as well as the world's top 100 of Forbes 2018. Truly incredible. Now, for those of you who are just tuning in for your first WiSE talk series, we're going to hear Barbara talk for about half an hour, but the fun doesn't stop there. Afterwards, we're going to turn over to a question and answer session. This is your time to ask all of your burning questions about Interstellar Lab, about Barbara's STEM journey, anything and everything in between. Now, as this program is geared towards getting young women interested in space exploration and helping support them in their own career journeys, we want to make sure that your questions are answered. So if you're one of these younger participants, a woman who's interested in going into the aerospace industry, I request that when you submit questions in the chat window, you include the hashtag WiSE. So remember, we'll hear Barbara for about 30 minutes, and then we'll have about 30 minutes for a question and answer. Feel free to send questions throughout her presentation. You think of something interesting she says or something that really is exciting to you that's a little bit puzzling, shoot off the questions and we'll make sure to get them answered. And without further ado, I'll hand it over to Barbara.
Thank you, Mimi. Hello, everyone. I'm very happy to be with you today. This is awesome that WiSE exists and that you guys are giving us women the opportunity to share with the community of women in STEM. Very happy to be here. Okay, let's start. Feel free to ask questions. I'm gonna go through the presentation and then I'd love to answer your question. So okay, share. I think it's coming. Okay, yes. So here we are. So I'm the CEO of and founder of the company named Interstellar Lab. It's definitely named, inspiration, a lot of inspiration from the movie Interstellar. In one way, we're trying to change the end of the movie, not making people leaving the Earth because of climate change and people can not get access to food anymore, and we're trying to develop the system and solution so we'll be able to stay on Earth and live in a world full of life, but also to carry life to other planets. So that's really the mission of the company. So it's ambitious as far as thinking, and the company is gonna be there, after me. It's a lot about inspiring people, and I want people to take over when my job will be done. The problems we're trying to solve. So basically, we're really making the link between planet Earth and Mars. And so we're looking at what's going on Earth right now and the problematics that we have, you all know, regarding climate change, pollution, and kind of in a short period of time, there is a huge need that we humans change our behavior and how we use technology on this planet. And more specifically, there is a need that we transition on our planet now to solutions that are regenerative and environmental friendly. What I mean by that is systems that are fully integrated when it comes to food production, water treatment, and waste management, so we can ensure in the future that everybody on this planet will be able to access food, water, and that everything will be recycled. No waste anymore, basically. And if you think about Mars and living on Mars, becoming a multiplanetary species, it's not happening right now, but it's going to happen very soon. Basically, if you listen to SpaceX and to NASA and to the plan is that in 15 years from now, we'll have the first rocket leaving our planet Earth to go to Mars and to carry the first human there. So it means that we have 15 years to prepare to go there, and how we can bring the life support system that we need to support human life on Mars, because the environment on Mars is pretty harsh for humans to live. And so we need to bring basically integrated system that can help us produce food, recycle the air, recycle the water, recycle the waste, and everything has to be in a closed loop and regenerative way. And if you just pause and think about it and look at the two planets, you'd be like, okay, it's interesting. The technology we need in 15 years from now on Mars are actually quite similar to the system that we need right now on Earth. And so this is what we are doing at Interstellar, is basically developing system and solution so people can, experience on Earth first regenerative technology before we go to Mars. Okay, the video is working. So that's a render of the product that we're building. So we're building, I often say space station on Earth, but so we're building station on Earth. We call them eBios for experimental bioregenerative station. They're designed as a completely closed-looped environment, completely sealed, meaning the air you breathe, the food you eat, the water you drink is produced in situ inside the station. We don't have an open supply approach. So we're really trying to bring everything, inside the station. The way a station is built and designed, it's very modular. So it means that we first design one module that is able to support life for a group of 5 people, and then we integrate different modules so we can build an entire village. So what you can see here are the different module, 5 module combines all together. We call the module flowers because they look a little bit like flowers, and we love to take inspiration from nature. And so that's a module. That's how it's organized. So it's composed of 4 units. One unit is the habitat, and then you have 3 other domes. Each dome is dedicated to a specific application. We have 2 domes for food production, so the aeroponics dome and the greenhouse dome, and we have 1 dome for water and waste treatment. You can see small humans here, so which give you an idea of the size of one module. But basically, it's going to be around, I don't know, wait a second, because I'm French, so I have in square meter, but it's around 7,000 square meter, 700 square meter. So I think it's around 7,000 square feet. That's for the ground surface of one module. So I'm going to go through a little bit more in detail of each module. But so here on the aeroponic module, so it's all the domes are environmentally controlled, sealed with specific temperature, humidity, and atmospheric condition. So typically in the aeroponic dome, we're growing food. The food we're growing there is really, it's much more, so we're looking for efficiency, productivity, and at the same time, recovering a lot of water, not using too much LED, so having an optimized LED system so we don't use too much power, and be very efficient when it comes to spacing. This is here a layout. This one is not optimized. We're actually gonna have new renders very soon to show how we optimize the layout. And here in this dome, typically the atmospheric condition, we will tend to increase the level of CO2 compared to, you know, the air you currently breathe right now on Earth, because this is what plants need to grow and to have better yields. And so atmospheric conditions are really different from one dome to another. And on this dome, on the aeroponics dome, we're gonna have cold and warm seasons. So we're gonna play a bit with the temperature because of the plants we selected to grow in the aeroponic system. They also need variation of temperature. So we were trying to recreate a perfect environment for them to grow. The second food production dome, so the main difficulty, let's say the main challenge to build a closed loop type support system is to close the food loop. Closing the food loop means that you bring all the food that will fulfill all the nutritional requirements for humans. And that's pretty hard because on the first module, we don't have, we don't have animals. So we need to fulfill the protein, the carbs, the fats. Then we have all the potassium, the zinc, and everything, very, very long list. So you need a lot of diversity of crops. And so the greenhouse, so it's also a completely environmental control dome. It was different temperature. The first greenhouse that we're working on is a subtropical greenhouse, because in a way, we're trying to bring a lot of diversity when it comes to food. And so we're trying to, have species and then plant species and plant selection of fruits people usually don't eat. I mean, for people who live in Hawaii, you're more familiar with eating this type of plants compared to us here in Europe or, in different countries all around the world. And so this is a subtropical greenhouse. So the humidity is going to be much higher. The temperature is going to be much higher that you have in the aeroponic system. And it has its own water irrigation and recycling system. So we're trying to recycle the water at each dome level. And then we have also a centralized system, but we're trying to really reuse the water as much as possible. So we don't use too much, and we can close the water loop as well. Then the last dome is the water and waste, the centralized water and waste treatment system, so which will take care mostly of the water that is coming from the habitat, and so what is called the black water, and that will turn into potable water. So you have different technology that you can use to turn the black water into potable water, and we're gonna combine and test different ones. I'm not going to dive into too much detail now. And then you have also the waste management system. So the waste management system, you have 2 types of waste. You have the organic waste that is coming from the food production dome, so the aeroponic and the greenhouse, and then you have the human waste. And so the goal for us is really to try to get as much as nutrient as possible from the waste, so we can feed it back to the plants and we can keep on growing plants. So that's the idea behind the waste management system, is really how we can get the most out of it to put that back into the system so we can produce more food and we can help the plants growing. That's a quick render of the aeroponic system we've been developing. So it's an A-frame aeroponic system with dedicated LEDs, Light are changing depending on the plant needs of what they like. We have this shape of an A-frame because it's allowing us to have we have much more space to grow food compared to traditional aeroponic, which is vertical or horizontal. Here with the A-frame, we actually double, sometimes triple, depending on the height of the A-frame, the surface where we can grow the food. It's also very convenient because we have a lot of different species, and this type of shape actually allow us to grow a lot of different fruit and vegetables that you usually can't grow in the aeroponic system. Alors, hop là. So one of the key challenge to design such a station is actually, before designing a station, you need to run simulation. So you need to be able to anticipate what's going to happen inside the station. So what's going to be the variation of CO2, the variation of O2, the need for water, the need for the need for nutrients. So when you build the station, you actually you know what you're doing. So before building the first hardware, we develop our own software and artificial intelligence to be able to understand better how everything is going to work. And I'm just going to pause this one, how everything is going to work and how we can size the different systems, the size of the dome, size the need of water tanks, the need of CO2 and O2 tanks. And so the first part of the algorithm we've been working on is the first to do the crop selection. Because as I said, the part that is very complicated is to figure out which crop we're going to put into the fruit production system so we can fulfill the nutritional needs, keep having diversity so people don't eat the same thing all the time, because otherwise you can go, a bit crazy. And so it's nutritional, it's physiological needs, but also it's psychological needs. And so we developed this algorithm. It's a quick demo of our software, where basically you put the number of participants, you choose if you have a surface optimization or if you want to consume less water, you choose which level of crop diversity you want, the preferred technology, and then if you want to cover all the nutritional needs. If it's a full coverage, or let's say if you're just taking care of, as you can see, iron, calcium, sodium, thiamine, and then you can optimize a little bit more the crops that you want inside. If you want coconut, for instance, you can choose that. Then you run the simulation, and so the algorithm will come up with a selection of plants and then work on how we can organize them in the greenhouse and in the aeroponic and in the aeroponic dome. Then it gives you at the same time the nutritional values and everything that each plant is basically bringing to the nutritional values. And so the idea behind this the simulator is to run different tests, to run different crop selection, to figure out what you want to put inside your station. And so then after you run a simulation, basically you can start launching the simulation algorithm to figure out what's going on inside the station. Because once you have the crop selection, then you can modelize how much CO2, O2, like the different flows based on the prediction of how plant will grow, and then you can see how your station is going to behave over time. So the way we did it is for each dome, we ran the simulation, and then we're looking at the variation when it comes to O2, CO2. This is what you can see right now, and then you choose basically on the habitat, the different domes, you can add parameters. So that's a software that is predicting and will also allow us basically to anticipate the behavior of the station. Then the next step, which we are working on right now, is to connect the prediction software with the station itself. So we're starting the construction of first, prototype. I'm going to go through that after. But the general idea is that as soon as you can connect the software to the station, then we're going to start getting real-time data from the station. So the station is full of sensors, a lot of sensors that are providing us data, and we know exactly what's going on, on real time, basically. And then what we do on the background is that we take this data with our simulation software to trying to understand what's going to happen, to anticipate the behavior inside the station. Meaning we can see that because the plants are at this stage of their growth, that they're going to need more CO2. Then in real time, we can see the CO2 starting decreasing. So we know we need to, blow a bit of CO2 inside the aeroponics dome, for instance. So that was the demo of the software and what we do, which is it's starting again. which is a very important part of designing a station. Here you can see some of the plans we selected. So the algorithm is really trying to optimize their crop selection, not only in terms of efficiency, nutritional needs, but also in terms of diversity. And that's something that's actually pretty new in crop selection algorithm, because if you look at what NASA has been working on, it was mostly focusing on getting the nutritional needs, and it was not looking into putting that much diversity into foods, because it's super complex to grow a lot of different crops because they have different requirements. And so on our side, we are taking, okay, it's not a risk, it's a challenge, and so you need to properly design and to understand. And so right now we are still running different tests, but basically we have selection between 35 to 60 crops to feed a group of 5 people. So you can see some of them. Those are the tropical fruits that you will have into the subtropical greenhouse. Comes the question of pollinators, which we often have when we do a presentation like this. It's like, okay, it's all ecological. You have plants, so O2 is mostly provided by plants, CO2 is mostly sequestered by plants, but how do you pollinate them? Do you have any insects? And so the first selection of insects that we're doing for the station, pollinators, we're mostly gonna invite bees into the station, which was the strategy also that they had in Biosphere 2. We don't know we don't know how how insects gonna behave inside the station, inside a completely closed environment. So that's gonna be for us also an experiment to see if we can in the same way. Bees are endangered species, and so can we protect them by having them inside the station? Can we study their behavior and make sure eventually we can be like a shelter to preserve living species and especially bees that are very important on Earth? Can we preserve them in our station? So this is a render of the first module. So we're planning, I'm going to give you a bit more detail about where we're planning to build a station. But this is a station on Earth, so it's very green. It's not Mars-like, but that's give you a quick overview. This one was designed with an extra dome for water treatment system that you can see here, which was focusing on biological water treatment system, basically what we called constructed wetlands, where we use plants to purify the water and to turn it into potable water. So this technology is a very low TRL, technology readiness level. So we need a lot of testing before implementing it. So you will not see this dome in the first station. And that is eventually how it's going to look like on Mars, 15, 20 years from now. We're still doing a lot of iteration on the design, so obviously it's not going to be the same material that we're going to use because they are, the condition living on Mars, the solar radiation is very, very different. Our goal is to try to develop systems so we can put them on the surface of Mars. And so it means that we need to find in our, so the domes are all inflatable or tensile structure, very easy to deploy with a deployment mechanism that basically is robotized. So it's not 3D yet, but we know how we want to do it. And the membrane, they're inflatable. Inflatable are amazing in space. They're amazing on Earth as well. The constraint that we have with Mars is how do we find a way to protect from solar radiation, but at the same time we want to get the light coming from the sun as well. So we want to keep this, transparency on the greenhouse dome especially. And so we'll see. Right now we're having big cushion full of air and aerogel on Mars. I can't say exactly what we're going to do because that was not the focus of the past year that we've been working on. We'll see. There's a lot of opportunity regarding water and ice because water is really protecting. If you have like between 50 centimeters to like a meter of water, you can get a pretty good shield to protect you. But it's too soon for me to answer a question about what exactly we're going to do on Mars. The thing I can tell is that the system inside is going to be very, very, very similar. So what's the plan? Where we stand? So the company is 2 years old. The first year was really R&D and spending a lot of time with NASA people and scientists. I'm not a scientist, I'm not an engineer, so I had to train myself, to teach myself, to learn, you know. And so the first year was about that. And the second year, we've been basically developing the software that you saw, the first design, and now we're preparing to build the first prototype. So the plan, so we want to build a couple of stations on this planet before going to other planets. So we're planning for next year to have two module build, one in Paris and another one in California. Due to COVID, the first one was planned in California. Now most of the team is a bit stuck here in Europe, so we're also adapting, you know, with what's going on. And right now we're working on the first dome prototype, and hopefully at the end of this year I will be able, you know, to take a video, share it with you guys inside the dome to show you the experience and how it is. We're planning on developing another station, two other stations, one in Saudi Arabia and another one in Japan in 2022. And then we have Florida, hopefully at the Kennedy Space Center, we'll be able to put one in 2023. We're also looking at Texas. There is a big space company there that's building rockets to go to Mars. So it will be interesting for us to have a module there to prepare to, how to prepare for life on Mars. So we'll see, maybe a Y as well, which is very appealing for us. Yay! Where there already are, you already guys have a lot of great analogs there. So we might be a good add-on to this experience. Okay, so living in the station. So the idea is as I said, is to build station, the module, then you add another module and another module. So you move from a module for 5 people to 10 people, 20 people, 30 people, and up to 100, 200 over time. And so the vision is that we start with one module and then we build an entire village. So the location that I shared with you before, we start with one module, and then the vision is really to build the future of cities and to open it for people to come. So it's not going to be open only for scientists to run their research and to work with us and collaborate with us. It's also be open for astronauts to have their astronaut training and to experience life in a completely confined environment. And most importantly, it will be open to families and to the general public. The idea is really half of the year you have astronauts and scientists, and the other half of the year you have families that are able to come and to experience life, a little bit like the Martian on Earth. And during 1 week, you're completely isolated, you separate from the world and you're inside, and you participate into the greenhouse activity, the aeroponics activity. And the goal for us is really for people to realize what it means to live in a regenerative way, and to understand that every action that we do in a closed system has an impact, because we don't, the Earth is okay, for some it's too small, for some it's too big, but it's too big for us humans to really see directly and immediately the consequence of every action that we're making. So when we're not recycling, when we do the way we produce food, for instance, we don't see immediately the impact on the planet and how we are harming our soil. Then we see that coming after years in a smaller closed environment. And it's exactly, I think what was one of the goals of Biosphere 2 as well. In a closed environment, you really understand much quicker how one action is triggering something else. And so my goal is that when people will come to the station and experience life there, I want them to have like a aha moments where, okay, understood. If I'm not working on recycling this organic matter, I'm not going to get nutrition solution for my plants to grow, so I can't eat. Or if I don't recycle, if I don't, turn the methane turn the organic waste into, biogas, then I cannot, cook. So no recycling, no cooking. but it's something I think it's important to see, and you can really experience that when you are a completely closed system. Then you really realize that. So the goal for us is to teach people how to live in a regenerative way on Earth, and then beyond. Really, like doing the little Martian on Earth, or as if you were coming to another planet for the first time. How will you live on this planet? That's what we're trying to do inside the stations. To share our vision of how we want to do that, we had one person in the team. She's awesome. She started a comic series where we try to present the different characters and explain how life in this eBio station can be. So we just have announced 5 characters, but they're actually going to be 6. 3 women, 3 men. We try to be equal, and so those are some, abstract of the comic series presentation of the characters. But we're really trying to make the link between living in a station on Earth, on an eBios on Earth, and then living on Mars. So we have different times, so it's like 2027, 2020, 2027, 2020, 2035, 2050, and we go through the life of the characters and how they're experiencing their life inside a station, and how they can contribute, to help humans become a multiplanetary species, but at the same time bringing back the knowledge on Earth so we can live on this planet. And so our character, they're like, and especially women, they're all badass women. So Keya, she's a life support system engineer and a life support system biologist. And over time she started as an intern. Then she get more and more knowledgeable, and then she became the manager of one station on Mars. They all have pretty, intense stories that we're going to share, and different backgrounds. They're coming from different countries, and so I mean, we all adore our characters. And we have Anna. Anna, she's a mechanic. She learned, engineering, mechanical engineering with her stepfather. And one day after living on Earth for a long time, she goes to Mars, and she's part of the first people who's going to go to Mars. So we're trying to share with people our vision of what it means to live inside a eBio station. The women in our team. So we're a small team. It's only a third of the team who are women. So I need much more, but we're recruiting, and we have three more women joining us before the end of this year. We all have different backgrounds. So as I said myself, I have no training in engineering nor architecture. I studied in business school. I was in finance. As Mimi said, I was managing my own fund. I was investing into robotic and hardware startups. I was very involved into deep tech, but I didn't study how to build and do stuff. When I was a kid, I was loving building stuff, doing my own thing, and being the little biologist. But then, 2 years ago, I decided I want to do this because this is what is really, this is my passion in life. So I just learned. So it doesn't matter if you don't have like the resume or anything. I think it's really a matter of like, you want to achieve your dream. So it's go for it. Don't let go, and just, okay, it's hard work. You need to work. But if you're committed to your passion, you can make it. Marie-Charlotte, that you can see on the right here. Marie-Charlotte, she's French. She studied also business school, and then one day she just left to Japan, and she learned Japan, and she spent a couple of years in Japan teaching kids, and be much more into education. And then she went back and she started working with Walt Disney company, and now she's also doing something that she's always dreamed of, is basically explaining how we can share the vision of the future with kids and also adults. We're trying to reach the kid inside the adults. Yishuan, she's coming from Tibet. So we have a very international team. She's a biologist. She's really passionate about plants. Her dream is to be able to sit into, a big nymphea. So if you remember one of the images I just shared with you before, that's one of her dreams. So we can't wait to put her into, our constructed wetland, and so she can sit on it. Very inspiring. She left China, went to England, and then to Netherlands to study biology. Awesome, really fun, awesome person. Everyone's awesome in the team. But Erato, she's from Greece. Erato, she's a PhD in solid mechanics. So she used to work at Safran. She was working on aircraft and different materials. And at a certain point, she was like, also, okay, that's great, I'm doing this stuff, but we are not really, helping the planet and trying to push humanity forward. And so, and she also joined the team, and yeah, super cool. Super cool. Maybe one day we'll have them do a session at WiSE Talk and explain their own paths. Yes, because they all have super incredible path, and very, very courageous women. So I think I'm almost done there, but that's where we have our office here in Paris. That's a render of the dome we're gonna put there. It's actually changing a bit the design, but hopefully by the end of December it will be in Paris. Then we're gonna build two of those domes in LA, so early next year. And so that's a combination of a greenhouse and aeroponic dome. So on this one, you have a section that is dedicated to the greenhouse, and then another section that is dedicated to aeroponics. So we're gonna try different things there. It's really for experiments. You can see our airlock. So it's a completely closed system. On the air part, we'll see exactly what we do if we the idea is that basically we call it baby dome. So you put baby dome, and then you can grow food to feed all the vegetables and fruits needs that you have for a family of 3-4. We're still figuring this out, and then you just plug it in. You just plug in, and then it's run by itself. So demonstration is going to happen end of this year, early next year. We're very, very excited about it, because this is going to be our first piece of hardware, and we're just crazy about it right now. Yeah, that's all for the presentation. If you want to join us and help us build, I mean, we're doing a lot of, okay, I don't know if it's, okay. We're doing a lot of, we have a lot of session actually in the company. We're inviting a lot of students to spend time with us. We offer like weekly stay and to share and to spend time with the team. As soon as we have the dome, it's gonna be much more easier to take you guys up there and for you to meet the team. So voila, I'm up for questions.
Margaret, this is so cool. Clearly everyone else who's in this session feels the same way. We have so many questions for you. I can't tell you how exciting it is to hear you speak about this, and also to make this direct connection, which I think a lot of people sometimes overlook when talking about doing this kind of space exploration, that it's not just to explore space, but to help us here on Earth. And I think you're making this very clear with Interstellar Lab, that this is to help us live better here on Earth as well, that by developing this technology, it's going to help us live more sustainably and regeneratively here on Earth. And I think that's so exciting. Okay, so just to get started, we have so many questions. You mentioned a little bit like what the plan is for the next couple of years as you start setting up these sites elsewhere. Like, where do you think we are a decade from now? If that is our first thing that we do in the next 2 or 3 years, what happens 10 years from now?
So 2-3 years exactly, we put the first station in place. 10 years from now, the idea is that we have 10 stations running on this planet, and that hopefully we will be able to, have technology that is much more affordable, and then we can spin off the technology. So meaning that anyone who wants to build a station or who wants to get a greenhouse and integrated, food production, water treatment, waste management will be able to buy it. So the first 10 years are dedicated to build a station. Starting 10 years from now, the idea is really to open the technology and to give it accessible to anyone. At the same time, we will be focusing also on applying our technology to space. So in the 10 coming years, at the same time that we're doing the Earth stuff, we're also planning on collaborating more and more with NASA and other aerospace players, so that we'll be able to put something. Eventually, my goal is to put a greenhouse on Mars. So we need a lot of iteration to get the product right, and I think 20 years from now, I think we're gonna get the right product. So yeah.
So exciting. And it's incredible to see what you've already developed in the history of Interstellar Lab. And so we have someone asking a question. What has been the most pressing or difficult challenge you have faced so far at this point?
I think in the life of the company, I think the most difficult part was it takes a lot of courage to, I'm young. I'm 35. I don't have the, I don't have the background. So it's in France and in Europe, it's not usual. Like people are having a hard time when you're trying to question the status quo, and when you're trying to, when you're a woman and you have balls. Sorry for what I'm saying, but as even though we're in a society which is like getting more and more, putting women more into more equality between men and women, I think the main struggle that I had at the beginning in France when I started was really that. It was getting people on board because I didn't have the resume, basically. Yeah. And then I did the same thing that I did with my previous company, is that I went straight away to the United States. So I went straight away to California, I went to San Francisco, I went to Los Angeles, and this is how the magic started to happen. Because I think, and it's and honestly, I love Europe and the United States, but there is something in America where people want to believe, and they want to give you the possibility to achieve your dream. So then it's a question of hard work and how committed you are to what you're doing. But it was very, very easy when I arrived to meet people in the United States, and I didn't know anyone at NASA, and then suddenly I'm with like all the people that have been working on life support system. I got the chance to meet very briefly Elon Musk and Jeff Bezos, and I was okay. I was in finance. I was running funds. I good career in venture capital in Europe, and in the US as well. But I was starting how very quickly I got to meet those people, and that gave me the strength and the courage to do it. And so and then it's a startup, so it's always like ups and downs. You need to get the funding, get the team, hire people, work on the product. But working on the product and trying to find solution, it's not something that that scares me at all. So I would say on my side, it's more the what I said about like being a woman and proving it's insane. But
thank you for being so candid about that. I think that when you have a really exciting idea, and I think if it's something that's unusual or out of the norm, I think it really takes a lot for people to support you. I think that there's often a very linear path to quote unquote success, and people think they really need to follow it. And I think people sometimes challenge others who try to come up with new ways of creating things. And it's really incredible what you've created. This is so cool and very, very exciting. And it's sad to hear that you encountered some difficulties of people maybe not being as supportive right away, or you having to wade through some nonsense in order to get the attention you deserve. But thank you for sharing that and for saying that it's not just, oh, I have an idea and then everyone supports me immediately, right? It's tough. And I think it's important, as you mentioned, also, when you're coming up with organizations that produce this incredible technology that's allow us to explore space as we never have before, it's not just about the science and engineering, right? There's a lot of things that go into developing this technology. So I think it's really interesting for all of us to hear about that. It's tough to have a startup, It's not
yes.
Developing. Okay, so something that's really cool about Interstellar Lab is that it's taking advantage of cutting-edge technology to do something that humans have been trying to do for a while. There have been a lot of different analog missions, and so we have some folks who've mentioned, hey, we have HiSeas here in Hawaii on Mauna Loa. Build another one here. We want you to come to Hawaii and build. And we have people who mentioned, Rodrigo was in the biosphere, 2 experiments. So, when you are designing something like this, how do you build off previous analog missions in order to incorporate what they've learned, what was tough for them, or how does that work?
So the first year, I actually so I didn't do myself an analog mission to be transparent, but I visited some of them, and also I read a lot of paper. All the team did, and especially about Biosphere 2, because Biosphere 2 is the closest is the closest project that was for me it was an experience. It was an amazing. It's amazing. Biosphere 2 it's so inspiring, and a lot of, I mean, it's crazy if you think about it at the time, you know, in the 90s and building this thing, and so it was very challenging technologically speaking, very, very visionary with a big mission. And so, and we're very fortunate that this Biosphere 2 existed prior to us, because there is a lot of things that we can learn from how they build it, what they experience inside, and the, you know, and the struggle. And so we can learn from that and try, you know, not to, we're gonna do they're gonna be like, you know, mistakes, and they're gonna be failures, and that's how you learn. You know, you never can get things right, you know, straight away. I mean, you know, yeah, it's a process. But the good thing is that there is a starting point, and that we can leverage on. And actually all this research about life support system and you know, enclosed environments, ecological enclosed environments, there is like over 30 years of like research that has been done, not only at Biosphere 2, but you also have in Russia BIOS 3. You have different analogs. A lot of people at NASA and at ESA who've been working on those topics, and it's a community of scientists and engineers that is very willing to share their knowledge, because there is a need that we move forward. So we're trying to, you know, helping the state of the art advance, and in partnership with the people that did it before. So yeah.
So cool. And also, you know, this is like the wonderful things of how we advance science, is that we can build off of our past knowledge.
Yeah.
Okay, so we have a lot of questions about specifics of the habitat, so I'll ask you some of those, and then maybe we'll ask you some questions about your own career exploration, maybe advice you have for others who are interested in following in your footsteps. So this one has to do with the stage you're currently in and future stages. Is Interstellar Lab planning on partnering with NASA, SpaceX? Have they done that in the past? Do they see themselves doing that in the future?
So yes, collaboration with NASA, we have a lot of different groups at NASA that we've been collaborating with, sharing our research, sharing what we're doing, talking about our design, getting feedback from different teams, especially from the Kennedy Space Center. We also have some folks at NASA Ames that we really like. Yes, we want to collaborate more with NASA. We're looking at what's going to be announced for the next SBIR in November. And I think they're going to be good stuff about, plants and greenhouses and all those things. So we'll see. What we want, what we're looking for in the future is to be one of the private company that will be able to develop the habitat and life support system that are needed for space application. And so in that way, I hope NASA, I mean, they're already, but they're going to come up with not now, soon with a program like the COTS program that's, helped started SpaceX at the beginning, but basically trying to find private companies to help design greenhouse on the moon and greenhouse on Mars. And this is how we see the collaboration with NASA. I'm very lucky that we have in our board of director Greg Autry, who's been recently nominated CFO at NASA. So he will have to step down, of course. It's for obvious reason, but it was very good for us to have him, because we got in touch with a lot of astronauts and especially looking at astronaut training and possibilities. This is also how we see collaboration with NASA in the future. Talking about, SpaceX, I love SpaceX. We have a lot of our engineers who are coming from SpaceX. They did their time there, and now they're looking to work, on the next step. They did the rocket, now they want to build the greenhouse, so which is really cool. I hope we'll partner in the future. I hope we put our greenhouse in a SpaceX rockets, and we'll see. Maybe we can do some stuff in Texas next to Boca Chica.
Very cool. I think all of us are definitely excited to hear about any future partnerships and see what they lead to.
Yeah.
Okay, a couple more technical details about the habitats. So are the power sources expected to be solar?
Good question. So we don't do the power ourselves. So as you notice in what I presented, you don't see the power part. So right now we're trying to optimize the consumption of energy, but we're not dealing with the technology to provide power, because we think there are different options and different people we want to partner with to see what's the best option. Especially terrestrial and space application is very different. So we're looking at solar here, but we're also looking. more at a type of like hydrogen power generator. So different way of providing power than solar. So we'll see. It's too soon for me to answer because we're running a little bit of suppliers assessment right now. But it's going to be a combination of this different system to provide the energy. Then we will need to test to see how it goes. Probably on Earth, the first one's going to be with solar. If it's in a desert, if it's in Paris, it's different.
So you mentioned this difficult challenge we have that maybe if we want to be able to rely on solar power, but also we want to stay away from potential cosmic rays or other things. Yeah. So that'll be a challenge that we can deal with. But it's really interesting to see how you're like, hey, there's a lot of creative ways to get power. We're going to focus on these complicated details, and then we'll see where we are in terms of what the most advanced power sources are. That's cool. Okay, I have a question about the software that you showed us and how you're able to figure out what crops to use. So how does it optimize which crops are there? We have a question asking, is it based on their metabolic pathway, or is it based just on the conditions, who's in there? Can you tell us a little bit more about how it would be customized, how someone might have one series of crops in one simulation versus a different series of crops in another?
Yeah. Alors, the way the algorithm is working, so it's first we have a big database that we combine data from different organizations about each specific crop. So we know, of course, CO2, O2, light, and then we have all the nutritional what they're bringing, and then for each crop. We have a modelization on how they grow and how so what's their the yield prediction, basically what is traditionally found, what is used right now for aeroponics. And this modelization of plant growth, we combine one of the approach from the NASA Kennedy Space Center, and then we needed to add some different parts because we have like some specific crops that haven't been studied and modelized using this model. So first you have this modelization. And so that gets to understand how the crop's gonna work. Okay, so the database, the modelization, and then the algorithm. So you put the number of people, and then the algorithm just like calculates, because we have another database for that, but calculate all the nutritional requirements. So it's very, very, very long, and that's gonna be also change. I mean, you need to make a decision, but it's like what's the amount of calorie? How do you split between carbs and fat? So depending on what you want to reach, the crop selection is not the same. So you define basically what you want to reach and what you want to put inside. Like, do you want to put the vitamins and all this stuff, or do you focus on other things? And then it runs the crops, and then it runs a selection. But then we have a lot of it's a much more complicated. There are a lot of different steps in the algorithm, but then it tried to optimize with the space, with the water consumption. You can adjust a little bit on what you want to optimize depending on what you're targeting, and then it's also it's calculating basically. When you get the food when it's produced, so that's why you need the yield prediction system. It calculates how much of this, let's say, sweet potato you're gonna eat. And then what we tell the algorithm is like, okay, we don't want people to eat sweet potato every day. And so we can tailor it a little bit by being like, okay, this is the type of menu, or ideally we want people to be able to eat this amount of fruit. And so this is where there is a lot of experimentation. So the algorithm is, the way we build it, super cool, so we can play with all the parameters all the time. And this is how you get different crop selection, because you play a little bit with that. So there is not like one answer about like what's the best crop selection, because it really depends on what you're trying to reach. But I hope I answered your question.
Yeah, definitely. Not potatoes every day like they feature in The Martian.
Yes.
And depending on what you said, something that's really exciting about this is this aspect of seeing the system produce different results depending on what your goal is for these kind of environments. So you mentioned like at the end how you're like, this is not just going to be for scientists. Like, my hope is that average families or citizens can join and be able to have these aha moments where they say, hey, actually my actions have these direct consequences. I forget that on Earth because the Earth is big enough for me not to know where my trash goes. But hey, the system reminds me that actually, in fact, something does have to happen to my waste. Something does have to happen for me to have clean water, clean air, etc. So when you're first going to be selecting people who will live in these, maybe before it is just like something that anyone can join, what are you looking for in someone who would be an astronaut, a potential astronaut in your system?
Would that be, you mean in terms of people?
Yeah, like if you're going to do these missions, these analog missions, what do you look for as an astronaut candidate?
Sorry, I misunderstood the question. It's like what we are looking for in the people, or what we are giving them? What's going to be the experience?
A couple questions being like, can I apply to live in this?
Yes,
right?
of course. It's a, yeah, yes.
In particular, like, you know, that in the astronauts candidate selection program, sometimes
yeah, I understand your question.
Grit, or what do you think is necessary to have someone be one of the first people living in these systems so that we can study and improve them?
So I don't know yet, because we haven't been like the questionnaire and the idea is really to have it open for as much people as possible. Of course, it's a closed system, so you need to be careful of who's going inside. But I think for me, yeah, there is a very interesting study that have been run by NASA, which is also about the type of people you want to have on mission. And the skills that you need, and especially for the people that are going to go to Mars. And there is a lot of soft skills that are required. So it's not only about the technical parts, and it's really about the soft skills and how you behave with other people. The being authentic, genuine, easy. And I think that's if you build up a crew and a group of people, you need a lot of diversity. You need a lot of happy people. So yeah, I don't know yet, because we haven't done it. We haven't done like the questionnaire, and we haven't been working on it now. But for me, I think a lot of the soft skill and motivation, and I think everybody should get a chance. So yeah, so no resume selection.
I think that's a good thing. And I think you even touched on this a little bit when you showed us this comic on how maybe you'll have to be very specific on choosing who will be your first candidates into your mission, right? But you showed us in your comic of the people who are living here have a wide range of backgrounds and a wide range of skill set. And so it's hopeful for me, and I'm sure for everyone else listening in, that maybe we can also be selected and be one of the people.
Of course.
You have a skill set. Okay, I want to ask you a couple questions just about your own career path. You've done so many cool things. And then you mentioned also how, this was something that just really excited you, and you had a different professional background than maybe other people who work in this field, but you were really excited about it and you pushed forward. So we have a question. Was there a moment that compelled you to do this? Was there a specific experience that inspired you to be working in these kind of regenerative life support systems?
Yes, it was. First thing is that since I'm a kid, but I think like most people here on the session today, so I was spending a lot of time in my room, and I was always playing like the little scientist, and then the little architect, and then I was building my small robots, and so I was playing with this different roles, which is very similar to what we're doing right now, because it's like multidisciplinary. And when I was younger, I was really into the different things. And then I remember in my room, I painted on the walls. I painted, plants and flowers. And so you will enter my room and it will be like all green. I remember my mom, she was like, "What did you do?" It was actually pretty. It was really cool. It was really pretty. And it looks like you're inside of a greenhouse. And so I think it's been there in my head for a very long time. Like it's always been there. And but like a lot of people that I think it's resonate with a lot of people, this like the station thing and the greenhouse thing, it's been in our global consciousness. There is something that we're all sharing here. So it's been there. And then okay, I had bad grades in physics because I hated my teacher in high school in physics. She was very mean to me and I was very mean to her as well. Yips. And and so I ended up doing business school. And so I did like a path in, big funds, finance, investing in companies, then going down and down to what I love, which was like robotic and deep tech. And after my last company, we're investing in a lot of and helping a lot of entrepreneurs build product. But the product we were building, they were not really helping the planet. And so I had a moment where I left the company. I was like, okay, that's great. I learned all this stuff, but I love the earth. I don't want to finance or do anything or build any product that is not going to help the problems we have right now on this planet. And I was looking at all the problems we have on Earth, the pollution. I was looking into integrated system because I strongly believe it. I mean, of course, everything is interconnected. So I was like, okay, let's stop think in silos. Let's focus on the integration of the systems. And when I was doing this work, this is when SpaceX, the boosters came back. And I had this aha moment where I was like, okay. The dream of becoming a multiplanetary species is actually going to happen because there's, stubborn entrepreneur, awesome company, and they're going to do it. Like they're going to build the rocket and we're going to go to Mars and it's going to happen. So I was like, okay, this is going to happen. And then I made the link. And then I was like, okay, I'll go. I don't care. I'm going to go. I'm going to find the people. We're going to make this happen because I dreamed of it, so it was a bit insane, but
but if it wasn't a little bit insane, I don't think it would be nearly as exciting, Barbara.
Yes, that's true. That's true.
Okay, I have two last questions for you. Thank you so much for sticking around a little extra. I know we have so many questions. Thank you for taking time. Okay, so the first question has to do with advice you'd give to a high schooler. So if someone's in high school is really, really excited about this, do you have any advice for them on things they can study or ways that they can move forward in their next decade of life to potentially do projects similar to this?
Okay, my first advice will be reach out to the companies that are inspiring you and that you want to go spend time with the people and meet them. On our side, we receive a lot of letters of high schoolers that are in France. You need to do an internship in high school, and they're coming and they're sending us letter, and I always invite them. Like and I think we're not the only company doing that. I think there are a lot of companies. So if this is something that you're really passionate about, don't be afraid of reaching out to people, of asking if you can visit and spend time with the team, because this is gonna happen. Because all of the people that are working in this field, we all know how important it is to give the energy to the younger generation. So my first advice will be like, don't be afraid to reach out. First thing. Second thing is maybe it's hard to figure out exactly which field you want to work in and which field you want to be specialized, but you will have to choose one because this is how the world is working now. So choose something you're really passionate about, if you're passionate about something, it doesn't look like work. So you're gonna learn so much and grow so much. And then if over time you realize that was not the thing, and then you're changing, don't be afraid of it, because there is always a reason why you learn something. And then if you're changing your path, you're going to use what you've learned. So don't be afraid of just following your passion, your instinct, and it's going to happen. But be honest with yourself. Like if you really want to do something, give yourself the energy, the motivation, work hard, enjoy life, but work hard. Like don't fool yourself, voila.
Totally. I think that's really valuable. Trust yourself a little bit. If you want to do something and it feels too hard, too difficult, or too impossible, that's not a reason not to do it.
Exactly. And follow your heart. It's telling you what to do. It's telling you, okay, you're going the right direction.
You even mentioned that, like, you had an aha moment where you were doing work where you're like, no, I want to be doing work that is definitely helping us here on Earth. So I think it's okay if we end up on paths if they're not the ones that we totally love, if we're able to have an opportunity to reflect and say, hey, I can shift, I can change, I can continue striving towards things that excite me. And so this one has to do, we have a lot of people asking of ways to stay connected to Interstellar Lab. So can you remind our folks who are tuning in, social media handles that we can pay attention to, a website, and if you offer university internships?
Yes, so definitely we're gonna, yes, for university internship, yes, you can reach out. You can send me an email directly, so it's Barbara, my first name, and then it's at Interstellar, like the movie, lab, LAB.earth, so EARTH. Sorry, it's a long email, but so feel free to shoot directly an email. Then regarding a website, so it's interstellarlab.earth. And you can find information there. We're going to update it. We have a Facebook page, Twitter page, Instagram. I'm not very good at Instagram, so the team is really focused on the product, so we're trying to post there. So if you guys actually want to do like if you're not in engineer, but you want to work on the content and stuff, you would definitely have room for that. So
an important point, we need all kinds of people to help work with these organizations, work in these companies. You don't just need a STEM background, we need everybody.
No, you need especially for this type of project, you need everybody, like very multidisciplinary, because everything has something to bring to build, such a project.
This, here, absolutely. Barbara, I think we've come to an end of our question and answer session. I just hope I can convey some of the excitement that everyone feels. I have all these messages coming in. You're doing so awesome. Thank you so much. I can't wait to see where this goes. When can I apply? When is this going to be built?
Thank you.
Enthusiasm for it. So thank you so much for sharing your expertise and your knowledge and your enthusiasm with us today. A big mahalo to Barbara Belvisi, the CEO and founder of Interstellar Lab. Thank you, Barbara.
Thank you so much. Thank you for having me.
And everyone who's tuning in, thank you so much for tuning in to today's session. Maybe you've made it to other sessions of the Women in Space Exploration series. A big mahalo from the bottom of my heart. And we put on this kind of educational programming and outreach opportunities because we want to help you. For so many of you who are tuning in, you're also excited and want to be working in this field. So please, if you have a moment, we have a feedback survey we would love to get your input on. There's a QR code on your screen. There's a URL link that will take you directly there. Just a couple of minutes to respond to our survey. We'd really appreciate it. And a huge mahalo to our sponsors, to Microsoft and to Hawaii Science and Technology Museum. And of course, a big, big thank you to Pisces, to Rodrigo, to Chris, to everyone at Pisces who has made this really wonderful talk series possible. Again, my name is Mimi Fuchs, and it's been a pleasure working with you. A big mahalo to Barbara. And I hope all of you have a wonderful weekend. Ahui ho.
Wow.